solving linear equation, simultaneous equation using Gaussian elimination method. Now, in Gaussian elimination method, the first thing is to turn the first thing to do is to turn the matrix into augmented matrix. So let's say we are given the first question: x1 plus 2x2 minus 3x3 is equals to 3. We have 2x1 minus x2 minus x3 is equals to 11, and 3x1 plus 2x2 plus x3 is equals to minus 5. Of course, we can solve this using determinant method. Now, to go further into this now, using Gaussian elimination method, the first thing is to rewrite the coefficient out, the individual coefficient of x1, x2, x3 in a form of matrix 3. Okay, so we are writing the coefficients at its end like we have done in. So this will be multiplied by x3, which will be equals to 3, 11, and minus 5. Now, the next thing to do is to join these two together to form an augmented matrix. So we have 1, 2, 3, 2 minus 1, 2, minus 3, minus 1, 1. Now, to join them together to become an augmented matrix, we use this sign to separate the coefficient of x1, x2, and x3 away from the constant term. So, in that case now, what are we doing in Gaussian elimination method? In Gaussian elimination method, we want to evaluate 3, 2, 3, 2. We want to turn them into 0, in which we will perform operations between rows and between row 1, row 2, and row 3. Okay, so we want to turn this 3 into 0. So for that to happen, we have to know that this is our row 1, this is our row 2, and this is our row 3. Okay, so how do we turn 2 to 0 and how do we turn 3 to 0? We can now perform an operation between row 2 and row 1. We can now perform an operation between row 3 also and row 1. So in that case, what operation will I do with row 2 that will turn these 2 into 0? So I can say that row 2 minus 2 row 1, because the value we have here is 1. Okay, so to turn 2 to 0, I have to subtract it from 1 multiplied by 2. Okay, and to also turn 3 to 0, okay, I have to subtract 8 from 3 multiplied by 1. Okay, now we are considering 1. So to do that now, I will write my row 1. You know that the row 1 is not changing, so I can say that row 1, 2 minus 3 everything and 3. Now since my row 2 is changing, which we can now call our row 2 prime, and our row 3 is changing, which we can now call our row 3 prime. So remember that our row 1 is not changing. Okay, in that case, to solve for row 2 prime now, I will take row 2. Okay, this is the entire of row 2. I will now subtract it from 2 multiplied by row 1. So in that case, this is with 2 minus 2 times 1. Okay, let's expand. Now we are now here. So this will be minus 1 over 2 minus 2 over 1. This is the over 1 affected. That will be minus 1 minus 2 over 1, which is 2. Now over 2, that's minus 1 again, minus 2 over 1, which is minus 3. And the constant term is to give us 11. We're considering, this is the formula we're considering, don't forget. 11 minus 2 over 1. And now we want to go into row 3 prime. Now for row 3 prime, we want to subtract 3 row 1 from row 3. So row 3 prime, I will start with row 1, that's 3, minus, okay, this is the formula we are using. 3 minus 3 over 1, minus 3 over 1, row 3 again, that's 2, minus 3 over 1, 2, row 3, that is 1, minus 3 over 1, okay, row 1 is minus 3, and row 5, sorry, row 3, that will give us minus 5, minus 3 over 1, 3. So we can now rename this to be our row 2 prime and this to be our row 3 prime. Now, having done that, we can now simplify this, and we have 1, 2 minus 3, we have 0, 0, minus 5 minus 4, 5, 10, 3, 5, and minus 14. Now, since at the beginning, what we wanted to do was to change these 3 terms to 0. Now we have accomplished in changing the first 2 terms to 0. Now the next thing we want to do is to change the last term to 0. Now, how do we change minus 4 to 0? By performing operations with row 2. Okay, so indirectly we can call this again row 1, we can now call this row 2, we can call this row 3. Okay, now, so that means we are saying to change row 3, to change this one to 0, we perform operation between row 3 and row 2. So in that case, what will our row, okay, we've changed, this is now row 3 prime, what is now our row 3 prime prime b? Okay, remember, but this is minus 4. We want to change minus 4 to 0, and we want to deal it with minus 5. Okay, so how do we do that? So we can now subtract 4 over 5 times the second row from the third row. Okay, this is just simple algebra. Simple algebra. Now I can subtract 4 over 5 row 2 minus row 3, such that when this one is minus 4. That will give me 4 over 5. And my root 3, so my root 2 here is minus 5. So that when this one is minus 5 and this one is minus 4, my answer will be what? Will be 0. Okay, because this will give us minus 4 plus 4. Okay, so with respect to that, we can now perform operations between row 2 prime and row 3 prime. So the first thing we do is to write what are not affected. 0, minus 5, 5, and 5. Now, we want to perform row 3 prime now. So we have 4 over 5 row 2. Row 2 there is 0, minus row 3, 0, or row 3 prime. And the next thing to do is 4 over 5 row 2 prime, minus 5, minus 4. And then 4 over 5 row 2 prime, 5, minus 10. Finally, 4 over 5 row 2 prime, 5, minus 14. So with that done, we will now have our final augmented matrix to be 1, 2, minus 3, 0, minus 5, 5, 0, 0, 6, 3, 5, and minus 18. Now, how then do we proceed from there? Remember in our question that it is related to x1, x2, x3. Okay, so if I start from row 3, I can say that 0x1 plus 0x2 plus 6x3 is equals to what? Minus 18. So this return to 0, we have 6x3 to be equals to minus 18, and we'll have x3 to be equals to what? Minus 3. If we go also from row 2, we have 0x1 minus 5x2. Okay, I'm multiplying it with x2 there, plus 5x3 is equal to 5. Okay, now we now know that this return to 0. We have minus 5x2 plus 5. What is our x3? Minus 3 is equals to 5. So having solving that, we can now have that our minus 5x2 is equals to 5 plus 15. And eventually our x2 will be equals to minus 4. Sorry, minus 5x2 is equals to 20. And our x2 is equal to minus 4. Now, if we now go back to 1, remember the coefficient here is 1. That is 1x1. The coefficient here is 2 plus 2x2. The coefficient here is 3 minus 3 minus 3x3 is equal to 3. Okay, so we can now solve the x1 plus 2x2 minus 3x3 is equals to 3. x1 plus 2, my x2 is minus 4, minus 3, my x3 is minus 3, which gives us 3. Now, so our x1 minus 8 plus 9 is equals to 3. So our x1 will be equals to 3 plus 8 minus 9. So x1 will be equal to 2. So at the end of it all, we will have that our x1 is equals to 2, x2 is equals to minus 4, and x3 is equals to minus 3. Now I want to take more example to understand further the process of solving using Gaussian elimination method. Now the main aim, as we said before, is to turn this 3 into 0, okay, by first turning it into augmented matrix, where we combine the coefficient of x1, x2, and x3, and we separate it using broken lines from the constant term, and thereafter we perform our row operations, okay, and then we proceed to solving for x1, x2, and x3. Now, note that when dealing with augmented matrix, we can interchange two rows, we can multiply a row by a non-zero factor, and we can also add or subtract a constant multiple of any row or from another row. Okay, so now let's take a quick example to understand better. We're given x1 minus 4x2 minus 2x3 is equals to 21. 2x1 plus x2 plus 2x3 is equals to 3, and 3x1 plus 2x2 minus x3 is equals to minus 2. Remember, the first thing to do is to separate x1, x2, x3, okay, by first writing the coefficients as 1 minus 4, okay, 1 minus 4 minus 2, 2, okay, let's try again. This is 1 minus 4 minus 2, 2, 1, 2, 3, 2, and minus 1. Now, since it is all multiplied by x1, x2, x3, and it is equated to 21, 3, minus 2. Now, let's change it now to augmented matrix. Change to augmented matrix. Now, the augmented matrix now becomes, first write down our usual 3, 2, minus 1. You separate the constant, the coefficient term with away from the constant by using broken lines. Okay, so that will be 21, 3, and minus 2. Now, having solved that, now we want to eliminate these two terms, turn them into 0. And like we have done earlier, we know that this is row 1, this is row 2, and this is row 3. Now, we are going to change row 1, row 2 to row 2 prime, and we're going to change row 3 to row 3 prime. Now, to turn this into 0, we're going to work with respect to row 1 with respect to, okay, w.r.c to row 1. So this is our 2, okay, so to change 2 to 0, we are going to subtract it from 1, That's subtract from 2 times 1. And this one, our root 2 prime will be root 2 minus 2 root 1. Since this is 3, also root 3 minus 3 root 1. Now, let us know that it will not always be like this. There are some scenarios that you might have to subtract it from decimals, but for ease of understanding, we're having 1, 2, 3. So, solving that now, we take the entire of row 1, okay? Since row 1 is not changing, so 1. Now, when we take row 2 minus row 1, this returns to 0, okay? And we'll have 1. We're dealing with row 2 now, okay? We're dealing with row 2. So let's try and make it a bit more understanding. And we also want to deal with row 1. Let's change row 1. So in that case, we'll have 1 minus 2. Okay, I'm following this formula here. Minus 2, and our row 1 is minus 4. Okay, and this one will give us 2 minus, following the formula, which is row 2 minus 2, and our row 1 in that case, following the green pen, is minus 2. Repeating the same thing, we have 3 minus, following the formula here, minus 2, and our row 1 in this case is 21. Okay, now let's apply the same principle to row 3. Let's become, for row 3, of course this will change to 0, right? And we'll have 2 minus, we're following this formula, row 3 minus 3 row 1. Okay, that will give us 2 minus 3 into row 1, and row 1 is in green, and that will give us minus 1. We're considering row 3, minus the formula is minus 3 multiplied by row 1, and row 1 is minus 2. Okay, and finally row 3 minus 3 row 1 from the formula, that's minus 2 minus 3, and multiplied by row 1, that's 21. So having done that, you can now go ahead. So this gives us 1 minus 4 minus 2, 21, 0, 0, 9, 14, 6, 5, minus 39, minus 65. Now the next stage is to convert this to 0. And how do we do that? We do that by subtracting the third row, okay, from the second row. Now we can write this to give us our row 1, this can be our row 2 prime, and this can be our row 3 prime. Now we want to change row 3 prime further. Okay, now we are performing the operation with respect to row 2 prime. Now to perform this operation, now we just say row 2 minus row 3 multiplied by 14 over 9. Okay, remember the last one we did, we took the coefficient of row 3 divided by row 2, just like simple algebraic equations. So such that when root 2 is 9 and root 3 is 14, that's 14 over 9, subtract, this will give us 0. So if you perform this operation now, we'll have 1 minus 4 minus 2, 0, 9, 6, 21 minus 39. And we want to convert minus 14 to 0. So we are going to follow this equation. So that will give us 0. And we have 14 over 9. Our root 2 in this case is 9. Okay. Minus our root 3, which is 14. Okay. And we can go again. This is 14 over 9. Our root 2 in this case is 6. And our root 3 is 5. And going further, if we repeat the same process, we have this to be 14 over 9 multiplied by our root 2, which is minus 39, minus our root 3, minus 65. Okay, so now having done that, we will have our final answer to give us 1 minus 4 minus 2, 21, 096, minus 39, and 00, minus 4.33, and minus 4.33. Now, just like we did earlier in our first example, we have x1, we have x2, and we have x3. Okay, so take the first row first, as 0x1, okay, so 0x2 minus 4.33x3 is equals to minus 4.33. So these two turns to 0, we have minus 4.33x3 is equals to minus 4.33. So our x3 is equal to 1. Now we can take the next equation. The coefficient of x1 there is 0x1. The coefficient of x2 is 9. And the coefficient of x3 is 6. Okay, it will be equals to minus 39. Now this will give us 0. That's 9x2 plus 6. Our x3 in this case is 1, which is equals to minus 39. Solving this will give us our x2 to be equal to minus 5. And finally, we want to take the last equation. The coefficient of x1 there is 1. The coefficient of x2 is minus 4. The coefficient of x3 is minus 2. And the coefficient, the constant term, is 21. So we have x1 minus 4. Our x2 is minus 5. Our x3 is 1. Is equals to 21. Now we can just solve for x1, which will give us 3. Now we have x1 is equals to 3, x2 is equals to minus 5, and x3 is equals to 1. So this is how to solve simultaneous equations or linear equations using Gaussian elimination method.